Okay, so welcome to what is our last seminar of first term. It's a little bit quiet in our room here because we don't have all of our first year students. They're just on their way back from a field trip, but they're going to come in partway through, hopefully. It's my pleasure to introduce you to Xiurui Guo. Xiurui is a visiting scholar at SPPH. She's here for a year. She's working with Mike Brower, and she comes from the College of Environmental and Energy Engineering at Beijing University of Technology in China. She received her master's and doctoral degrees in environmental economics and ecological planning from the School of Environment at Beijing Normal University. Her research focuses on the economic valuation of air pollution, vehicular emission reduction policies, air pollutant reduction options, energy policy on carbon mitigation. She has participated in some research projects on air pollution control options, such as analysis of emergent control scenarios of heavy air pollution in North China, and cost estimates of air pollution control measures, which provide scientific support for policymakers of the Ministry of Environmental Protection in China. And I think it's really interesting that Sherry's actually here with us at UBC to kind of broaden her horizons with respect to the work that she does. So she's learning more about kind of the air pollution models that we use for epidemiologic research while she's here, so she can bring that perspective back into her work on environmental health policy and economics. So that's fantastic. Sherry, can you please turn on your microphone? So welcome.
Okay, welcome. I'm Xiurui Guo. It's Sherry. You can call me Sherry. I'm glad here to present my research here. Actually, I came here 3 months ago, and I come here to learn to study a new research direction about air pollution exposure. Actually, I'm also studying English speaking and listening. Maybe at the end of it, the communication is a little difficult for me a bit late. So anyway, I'm trying to make me clear and I hope my presentation is something is helpful for you. And I don't know this topic is relevant to your research. I don't know if the research, anyway, I think it's maybe helpful information for you. My research focus on the scenario analysis to vehicular emission reduction options in BTH region China, in the North China. And outline is the fourth part. First is the general and brief introduction to air pollution situation in China. And the rest three part is about research background, research question, methodology, and the results and conclusion. And the first is the air pollution situation in China. Maybe it's, as you know, it's not news. There are severe air pollution of megacities in China. As the left picture shows, at the same place, the haze days, bad days, and good days, the comparison of the same place, and it's obviously air pollution is poor visibility. And the red picture shows that the process from the haze appear to disappear. And on second days, you can see that we cannot see the building at all. It's severe, yes. Facing so severe air pollution, people have to wear all kinds of masks. Maybe someone makes them cute, and someone it's weird, yeah. It's strange, it's weird, but I mean maybe it's the most effective, yeah. And from the global satellite picture, we can also it's obvious that this is the PM 2.5 is the main component of his. It shows that in the Southeast Asia, it's severe air pollution. This is China. This is North China. Beijing is here. It's the largest PM 2.5 concentration. And maybe you are familiar with this table, this figure. And it shows that in China, the burden of disease attributable to the leading risk factors, the ambient PM pollution ranking the fourth in China. And also, World Bank reported that the economic loss of health damage from mortality and morbidity resulting from PM10 air pollution amount to 2.8% of total GDP in China. This table shows that this is reported by the China Ministry of Environment Protection. It shows the number of cities meeting the air quality standard in key regions in 2013. We can say that it's that a few days, very few days, which can meet the air quality standards, especially for PM10 and PM2.5. There are very few days who can meeting the air quality standard. Actually, in last year, among the total of 74 cities, there are only 3 cities meeting the new air quality standard, and 75% of cities cannot meet the standard. This picture also published by Ministry of Environmental Protection China. It shows the number of hazes in China, and the dark color shows the largest, the number of the hazes, and this is some big megacities. Hazes very large number. Actually, the average hazes amount to 1 month, more than 1 month. And most of the cities in North China experience 50 to 100 hazes, and some cities even have more than 100 days with probability. So it's so severe air pollution. Maybe you're curious why it's so severe air pollution, and researchers argue that the main possible reasons include that rapid economic development, approximately 8%, and fast urbanization. And now in China, there are more than one half of people live in the city, and which means more energy consumption and more industrial like that. And the second is fast industrial development, such as large steel, large cement production, and a large amount of material and chemical production, etc. And third is, I mentioned, a huge energy consumption, and it's kept increasing in recent years, and especially dominated by coal, and but the proportion was 3/4. And last but not least, rapidly increasing vehicle population. China has become the largest car production and consumption in the past 2 years. This is my focus on my research about the vehicle emissions. Actually, facing severe air pollution, Chinese government is put much effort to address this problem. Do you know that in China, ordinary people in village even know about PM 2.5? Yeah, it's real. It's real. So the public is very concerned about this problem. So the government put much effort to address this problem, such as in past 2 years, there are 3 important documents issued by State Council, such as the new ambient air quality standard, in which PM 2.5 limit value was ended on the first time, and the same year, the 12-year plan on air pollution prevention and control in key regions issued by State Council, in which the 3 key areas were defined, including 117 cities of 19 provinces. The study area on my research is one of 3 key areas. And only 1 year after that, in 2013, another important document, Air Pollution Prevention and Control Action Plan, issued by State Council. And experts said it will be the milestone document because it's the most aggressive and the most ambitious action plan, which much more stringent requirement than before. Sample size, it is impossible to finish it because it's very stringent requirement. And to support to finish the national action plan, most megacities formulated that their own action plan also gave their air pollution emergent actions. So the government is trying to address this problem. Maybe one good example is APEC Blue. Do you know about that? It's a new word after the APEC meeting held this year in November in Beijing. Because the APEC is an important economic meeting, development meeting in China, in Asia Pacific Economic Council meeting, and it held November. In this season, it usually has many days, many haze days, so it's a severe situation. So government takes some temporary measures to address this problem, such as some key factory, almost 10,000 were shut off or restricted to produce temporarily, and the private cars can only run on the odd or even days. Government cars were off, and most of construction activities were stopped, and some employees had 6 days of holiday. Maybe it's good news. It's never happened before. And not only these measures, not only for Beijing, but also for other surrounding provinces. And finally, these measures result the 40% and emissions reduced, and finally the reduction of 30% PM 2.5 concentration. So the result is satisfactory and have blue skies during these days. Okay, the above is the general brief introduction of air pollution situation. Next is my research and background. I mentioned before, my research is focused on vehicle population. Actually, in China, vehicle population keep increasing rapidly. Like the figure shows, it's very fast. The number of total vehicles reached 240 million in 2005 and in 2012. And also the studies show that the vehicle contribute a substantial proportion of total pollutant emissions. Chinese yearbook of vehicular pollution prevention and control show that the pollutant emission trend during the past 30 years, it keeps increasing faster increasing trend. And this is the 3 key areas the air pollution control in China. My study is Beijing, Tianjin, Hebei, BTH region is one of the key area. This area, BTH region, there are totally 13 cities, which the regional GDP amount to 11% of total in 2012, and 100 million of population, and 7.8% of total in China. There are 11 cities which in this region the air pollution is very severe. There are 11 cities which ranks top 20 of the worst of air pollution in China, and 7 cities ranking top 10. So it's severe air pollution. And the average days meeting air quality standard amount to only 30%, and there are 10 cities where more than 1 year cannot meet as standard. The main pollutant is PM 2.5. About the vehicle population in this region, it keeps increasing about 10%, especially in Beijing, is 14% increasing rate. And For facing this problem, and the government taking some vehicular emission reduction policies, like that private license plate control policy, so as to slow down the increasing rate of vehicle population, which means people want to buy a new car, he have to get the license plate using lottery system. It's not very easy because the probability is very low, so it's not easy to buy a new car in China, in Chinese megacities. And the second is updating the vehicular pollution emission standard is for new car. The government is updating the emission standard every several years, and the new standard and the more stringent standard for new cars, and phasing out the high emission cars and old vehicles. It also called in China is also called yellow label card. Yellow label card is maybe its number amount a small proportion of total vehicles, but it amounts a big proportion of total emissions. So phasing out the high emission cars is important. Another is promotion of new energy vehicles, such as battery vehicles, hybrid battery electric vehicles, and hybrid electric vehicles, or natural gas vehicles, such as to substitute some old vehicles. And the other is updating the new vehicle fuel standard. It's for fuel standard for fuel cars, and stressing the inspection and maintenance in used cars. And because of data limits, in my research, there are the first four policies included in my research, and the other option not included in my research. And the second is research question and methodology. And since the government have taken some vehicular emission reduction options, so the question is how much is the future vehicular population emission in BTH region, and how much can be reduced by the reduction options, and which options can reduce slightly, and how much is the pollutant reduction potential in PTH region. And the methodology using the method of scenario analysis. I don't know if that scenario analysis this matters. I introduce it to in one word it is to demonstrate what would be like after some public policy implemented in the future. It's the scenario analysis. So in my study, I need to define some scenarios. That is which is the scenarios of vehicular emission reductions or options. So first scenario is BAU. It's business as usual. It's no change. It's like usual, like before. It's no change. It is BAU scenario. And this four, the green, show that this four is four single options. One is ESU. ESU is emission standard updating. That is to updating emission standard every several years. And the HVE scenario, it is higher emission vehicle elimination. It's to phase out the higher emission vehicles scenario. And the next is NEP, new energy vehicle promotion. It's to promote the new energy vehicles, like I mentioned before. And another is LPR. It's for LDVs. LDV is light duty vehicles. It's LDV's population regulation. It is like the license plate control to slow down the population. increment. So is this LPR scenario? So this is four scenario for the single option, so single control options. And the last is the integrated scenario. It's integrating the these single options to see the integrated reductions. And after this 6 scenario was defined, and I will to calculate or estimate the vehicular emission in the future, like 2015 and 2020. We used some method to calculate vehicular emissions for each scenario. So for different scenario has different emission in the future. The next slides I will introduce the scenario specifically, more detailed. And this is ESU emission standard updating I mentioned. This is in this scenario I set the year. In that year, some new standard were introduced and applied into the new car, such as for Beijing, the national 5 standard will be introduced in 12-18 year, and this 12-16 is the improved scenario. And for Tianjin Hebei region, and the national 5th state standard will be introduced in 12-16. So this is the scenario is set for in different year will set the different new emission standard. Another is high emission vehicle elimination. This scenario I set the before some year some kind of vehicles some kind of high emission or old vehicles must be scrapped before that year, such as Beijing. In Beijing, before 2016, gasoline vehicle with national 2nd standard must be scrapped before that year. And for Tianjin and Hebei, yellow label cars, which is the higher emission vehicles, and motorcycle with national 0 standard must be scrapped before that year. This is this scenario. And for the NEP, new energy vehicle promotion, I said in such years to 2015 in Beijing, such as for light duty vehicles, some numbers of BEV and HEV. BEV is battery electric vehicles, and HEV is hybrid electric vehicles. So for I said in 2015, for light duty vehicles, 80,000 BEV and 20,000 HEV were introduced, were promoted by government to apply into to substitute some old vehicles. And for Tianjin Hebei and the number of BEV or HEV, this here LNG is liquid natural gas, and the CNG is compressed natural gas, but maybe introduced and in this year. This is the NEP scenario. So also the above 6 defined reduction scenario was set, and I need to calculate and estimate the vehicular estimation in the future in the 2015 and 2020. I use this formula to calculate. There are 3 important variables, which is VP is vehicular population, and the VKT is the vehicle kilometer traveled per vehicle, and the emission factor is EF. So for different scenario, for each future year, there are different value for the VP, VKT, and the EF. So I need to calculate or estimate the VP, VKT, EF, this variable, use something method. So next, I will introduce the method to calculate. For VP, the vehicular population prediction, people usually use this model, the Gamper's model. It is model the relationship between vehicle per 1,000 people and GDP per capita. The relationship is like S shape. So using this model, I can predict the vehicle population per 1,000, like this figure, and then I use the grid model to forecast the population growth, like this model, and then I got the result of projected vehicle population trend in this region in the future years. This is Beijing, Tianjin, and Hebei, the three sub-regions. And for Beijing and for the three sub-regions, the number of the vehicle population still keeping increasing, especially light-duty vehicle, like this red one is keeping increasing fastly, except for motorcycles, because there presently there are some policy to control the motorcycles. And another is VKT variable. Prediction VKT for different types of vehicles in this region and was predicted according it's associated with vehicle population per 1,000 persons I predicted before. And VKT for other vehicles was estimated based on their associated with GDP. So I can predict the VKT the number in the future. It shows that a flat increased, a little bit increased in the future. VKT is value, its vehicle kilometers traveled. So the methodology of after that result and conclusion. But the result, the emission, this is on BAU scenario, it's basic business as usual scenario. It's not if we have if we don't have any additional control options, the total NOx, PM10, and the carbon dioxide emission will keep a slow increasing. And CO and HC, the hydrogen carbon and the carbon monoxide emission will decrease because presently in Beijing implementing national force standard. And this is emission reduction scenario for different scenario. It's a comparison the different scenarios. It can show that HVE can reduce more CO, and HC is the blue one. It can reduce more reduction. And for PM10 and the for PM10 and more effectively in short term than in long term. So we can show that. And the reduction and the LPR, it is the license plate control options. It would be significant. It's like the purple one. The purple one, it's like it's a bit increasing in the future, but excluding NOx, it has no effect. But the LPI scenario can have big carbon. This one have big carbon emission effect. And for another sub-region, Tianjin and Hebei, it's different. But these two sub-region has the similar trend. And under BAU scenario, and the Tianjin and Hebei province shows So a similar trend is all the pollutant keep increasing fastly. Especially PM10 and NOx and CO. And in the scenario, in the control scenarios, it shows that ESU is emission standard updating for the new car. This scenario would achieve a substantial. It is the blue one. The highest is the integrated scenario. It certainly is highest. This is the ESU emission standard updating. It's very substantial reduction and will increase in the future year. So ESU have achieved a substantial reduction, and the NEP, this red one is effect is not significant. The last picture show is the summary of the results. It also shows that this is ESU emission standard updating. It's have a big effect than the other scenario. And for the HVE, its high vehicle elimination scenario has big effect in short term than long term. And the main conclusion is the light duty vehicle population regulation can reduce CO, HO, and the PM10 significantly, but excluding NOx. And it also has big carbon mitigation effect in Beijing. Another is the emission standard updating scenario. It's the new standard scenario. It would achieve a substantial reduction for all the conventional pollutants in BTS region. And the elimination of higher emission vehicles can reduce more CO and HC emissions more efficiently in short term than in long term in Beijing. But this scenario can reduce not significant effect in other sub-regions like Tianjin and Hebei. And the promotion of new energy vehicles, the effect would not be significant because in my scenario, the number is not big. The number is promotion new energy vehicles not so big due to the constraint of existing economic and technical level. And the final conclusion is the integrated scenario. It shows the largest emission reduction potential, which means the largest reduction potential, we can take all the possible scenarios, all the possible options, the biggest scenario. Maybe in 2020, and compared with the BAU scenario, and we can reduce emission of CO, NOx, HC, ATM, and different proportion of emission reductions. The biggest is for the CO and NOx, HC, but for PM10, it's a small proportion. So according to the conclusions, I have some policy implication to the policymakers. One is the continue to implement more stringent vehicle emission standard. That is from the emission standard updating scenario. So the government need to continue to implement more stringent vehicle emission standard, especially in Hebei and Tianjin sub-region. Now the emission standard is not stringent. So in this sub-region, we need to continue to upgrade emission standard. Another is accelerate the elimination of high emission vehicles. That is to phase out the high emission vehicles or old cars or old vehicles, which means because the high emission vehicles emit the most of pollutants, even amount a big promotion total emissions, even if they have even if their number is not big. So accelerate the elimination of high emission vehicles. Should be strengthened. Another is strengthening the promotion of new energy vehicles. Just I mentioned the promotion of new energy vehicles. The effect is not significant because the technology and is not familiar. It's not so good to promote because some limit of technology. Maybe the new energy vehicle is expensive, so government should take some options to promotion the new vehicles, including economic and the technology and these things. And the last is continue to implement the vehicle population control policies within a reasonable range. It is the population control policies, which means license plate control policies. Presently, in China, there are only several cities like cities like Beijing, Guangzhou, and is taking these policies to control the license plate. So government continue to implement this policy because the population vehicles is keep increasing. It will maybe it will offset the reduction effect. So it need to implement it. So the next is the last slide is it's the future research directions. After my research on the scenario analysis to emission reductions from vehicles, I like to know that the vehicle emission and the health impact from vehicle emissions. I'm interested to know the health impact or health damage from the exposure to vehicle emission. So I think I need to do estimation of exposure to vehicle emission. So which is also the reason I came here. I came here to study to study how to get exposure of air pollution. And another is then after I get the exposure to vehicle emission, I can to estimate IL's cost or benefit. Cost from vehicle emission and the benefit maybe is from vehicular emission reduction policies. So if the government before the government taking some options, and it needs to know the cost and the benefit of the options. So maybe the benefit is from vehicular emission reduction policies resulting from the reduced health damage from vehicular emission reduction. So this is my the future research directions. Actually, I have another paper on the health benefits, health cost of the vehicular emission reduction emission. That is I use the integrated assessment to estimate a health cost. That is the first step is the estimation for PM, maybe some other pollutants, PM emissions on the defined scenario. And this is estimation. This is estimation emissions. And second is simulation of the concentration. It's from simulation is some models, and then I need to explore. It's the first step, first ideas to explore to get the highest resolution exposure about population exposure to the air pollution, and then estimate the health impact due to traffic-related air pollution, and then in economic valuation the health effect results from vehicular air pollution. That is the idea as an integrated assessment. It's all from the options of policy and to get the economic valuation, the benefit or cost, and then to do the cost-benefit analysis. It will be valuable to policy makers. And then that's all. Thank you for your attention and the question.